Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today's problem is a little bit of a beaten path. You obviously see the patterns that I promote here. Formula, another formula, to derive the formula, to write an equation, known, unknown, forget about physics, it's math, solve the system of equation, find all unknowns, put the values. This way we're promoting this knowledge of formulas and how you apply those formulas to the real world, and this gives you a better understanding of the physical effects that go underneath. It's a little bit different from lectures, when they tell you about the laws that have been established and general view, and you cannot really solve any problems. So solving problems complement these lectures, as boring stories about things that happen. But it's not actually how real physics works. Real physics works that they have a world, they observe it, they do experiments, and they obtain something. Like, for instance, 400 years ago they obtained that G equal 9.8 meter per second. It was very difficult for them to do it because they didn't have good clock, good watches. They didn't know how to measure accurately, and they didn't have a pattern of the knowledge, no methodology. Based on this, some formulas have been introduced. For example, V final minus V initial equals GT in this case. They could verify this formula, and based on this formula they actually obtained G. Well, then another formula was introduced about D. D equal V initial T plus GT squared. And then another about D V final squared minus VI squared divided over 2G. One formula, another, third. And basically the way the science work, we have some observation and then some theory, and based on this we have some facts. And those facts are based on those formulas, not necessarily on this alone. So we can take step 1, step 2, step 3, and we have some effects that we can obtain and measure, and if we receive what we expect, everything is fine. We can do another experiment, and another, and another, and if we have all those experiments, we have the predictable result, the results that predicted by those formulas. It's very good sign. It's like always try to solve the problem with 3 different methods and obtain the same end result. But what's important that you may have only one single result that contradicts all those formulas. And this destroys all your theory. You have to build completely new theory, and this is how science develops. I can show you millions examples, like from classical mechanics to quantum mechanics, and all was based on the fact that then electron, is it a pattern, is it a particle, or is this a wave? Because suddenly they started to see behavior of electron beam when it hits the atom, and suddenly they have the results that they couldn't explain in terms of mechanical theory. So one thing is important, is to do as many experiments as you can. It's always a good sign if they all match. But if it's only one is not matching, it already means a big trouble. The whole theory has to be evaluated. So back from this lecture, Let's build an experiment nowadays. How can you find G, for instance? And I suggest to use a camera, and I give you a hint. Imagine that we have a acceleration, body with a constant acceleration. What body with a constant acceleration is the most easiest to recreate? Hint, pause. Of course, free fall. Because all you need to create a free fall, you let the body drop. And it calls free fall not because there is no money involved, but because it's falling free of any forces. Nothing acts on this body except of gravity. Gravity that creates this force, and force creates acceleration, but I'm a little bit ahead of myself. All I'm saying is that if we need to observe the movement one-dimensional with constant acceleration, all we do is have a free-falling body. So let's imagine that free-falling body is falling down, and somewhere here is a screen. And on this screen we have a ruler. We have like a ruler, and we have marks, and let's say every millimeter or every centimeter, and this is the body. And somewhere here we have a camera with a lens, and this camera gets an image. And let's say what happens if we will let this body fall, and this body, and at that particular moment we press the shutter down, we press, and we open the shutter for predefined moment of time. Pause. Hint. Of course, at that moment of time we will obtain the image of this body, and it will be somewhere here. Let's say it's reverse. Doesn't matter. I don't want to go into the detail how optics works. It's like ahead of me, 1 year ahead, because I have do 10 playlists in mechanics, 10 playlists in electricity, 10 playlists in gases, and then I will come to playlist about optics. But for the time being, the body is here, it is here. And for duration of the time that shutter is open, it will be recorded this line, well, upside down again. And then the shutter would be closed. So, on our image, on our picture, we will see a blurred line. And of course we will see, this is how our image will look. There would be this ruler, and some from here to here there would be a blurred line. And blurred line will represent us, the body. And we know the time for which the shutter is open, and hopefully we can calculate this distance through this formula and connect it with acceleration g, right? And then when we measure this distance, and to measure this distance, we don't have to measure it, it would be like those marks. You have to read what those marks on the ruler, and the ruler can be anything. Like for example, ruler can be this. Put it on the wall, let the body drop, receive this image. The image would be a blurred line, and you will know exactly how to relate T and G, and that's what we will do here in a moment. So that's an idea. Well, now let's go to the formulas. Because we have the idea, now have to write it. So we have the body, and it covers some distance, and this distance would be, let's put x1, because this would be the distance that the body will wall, and it will take time t, and so x1 would be, pause, free falling body, correct, v would be gone, initial, and so the distance would be only gt squared. And I put capital because that's the whole distance. And what happens if the body is only here? This would be xt, and this would be xt, and this would be x1, and this is t, and what time would be left for this? T minus t small, because the shutter is open for the time t, and we will know time t from the characteristic of our camera. So we can tell that x2 equals g t minus t squared over 2. We saw this formula already in the previous problems. Here the same approach. We can put 2 here, g here, and we have received t squared equals square root of 2, no, not square root, t simply, t squared, I'm running ahead of myself, 2x1 over g, and we know t minus t squared equals 2x2 over g, and we can take the square root, and it will have t equals square root 2x1 over g, and we have here square root of this, so it will be gone, 2x2 over g, right? And we subtract this from this, so t is gone, or I can put it here and move it other way around, but it is just faster for me to subtract this from this, so it would be t minus t, I subtract this from this, equals square root 2x1 over g minus square root 2x2 over g. T minus t will be gone, t would be left, square root t over g I will factor, and I will have square root of x1 minus square root of x2. Okay. And typically this is how we solved before. We solved, oh, x1 is known, x2 is known, let's find t. But let's reverse this. This time around, we make a picture, we see on the picture this image, and we will see those marks for the distance, and so this distance will exactly tell us x1 and x2, how far from this vertical, from initial point it is. And we know x1, we know x2, right? x1 of course bigger than x2, we know 2, and we know t, and so we can find the g, what it is. So we measure this, we measure that, we measure this, and we can obtain g. I don't know, let me wipe this out. And imagining that t is known, it's our shutter. x1 is known, we will see it on the image. x2 is known. We can find what g is. We put square root of g here equals square root of 2 divided over t, and here would be square root of x1 minus square root of x2, and then we want to get rid of the square root, so we take a square of left part and on the right part, and we have t squared, and here would be, oh, I just wrote it, square root of x1 minus square root of x2 squared. And basically this would be our result. So the procedure of our experiment, would be, we will take the camera, and this camera has to be with manual exposure, so we can control the time t lowercase. This time t, we will be controlling it on the camera. We will start making pictures, and beauty here is that we don't have to connect the time that we release the ball and the time we press the button. Because sometimes you release the ball and go here, and only then you will press the button. And nothing will be there. Sometimes you release the button before it even goes. But sometimes you will release the button, release the ball and press the button kind of simultaneously. So you will have many images with different x2 and different x1. It all depends on this time t, but we don't care about this t in this equation. So you will measure x1, measure x2, put t, what t you put this in, and you will put your results. And you put those in the nice table. First experiment and G would be 978. Second experiment and G would be 9.6. Third experiment and G would be 10. Fourth it would be 10.1. And you write it down, and then you will change shutter time, and you will see different x1 and x2, and you will obtain different results for your experiments, and then you will get an average. And if the average, and you see, it always 9.7 different. You should not expect that it would be exactly 9.8, because there is always some kind of inconsistency. The shutter tells I opened for 1/30th of a second, but in fact it's 1:30.5 or 1:30.2. There is always some noise, and it will be here, reflected here in different numbers. Then you have to take different camera, because maybe this camera, it always have 160, but it always some internal problems, and it's actually a little bigger than 160, or a little smaller. So you should take many cameras, do different results, compare this, obtain the average, and hopefully this average would be 9.8. And this would be your experiment that you will do. Of course, there are things that you can think ahead of time. Like, for example, your time, your shutter time. You could kind of predict what shutter time you should set in the beginning. How? I will just rewrite this formula again. This formula for time is this, and this is, like, for example, let's say you drop it and you have 1 meter of the distance that you record. Like, let's estimate what shutter time you should set originally. For example, if x1 equal 2 and x2 equal 1, then your time would be square root of 2 divided over 10, roughly. Square root of 2 minus square root of 1. This would be square root of 0.2. It would be roughly, this square root roughly would be 0.45. I explained how I roughly easily can obtain what is square root of 0.2, that is 0.5. This would be 1.4 minus 1 multiplied by 0.4. And it would be something like, very roughly, right, 0.25 seconds. So you can take your camera and see whether this camera has this setting or not, because maybe it doesn't have this, maybe it's too long. What will happen? You can reverse it. If t you know, then you can find what x1 and x2 you should expect, because you expect g to be 10. And so when you set all of this, you maybe will have to drop it further up. When you set all of this, you're ready with your experiment, and you do it, and you obtain number, and if this number is close to 9.8, we're lucky. If it's not, we have to look into why it is not so. Maybe our theory is wrong. Maybe there are some systematic error in your experiment. Maybe your camera tells that the shutter speed is 1/10, but in fact it's 1/20. All those kind of things, one lead to another, but this is actually what presents a real science. A real science is how it's done, because any question is allowed in science, and any experiment is allowed. And if predicted result is the same, like really obtained is one thing, but if predicted result and final result are different, that's also a result. So I hope this problem, although it was a little bit unusual, was interesting for you. And if so, subscribe, bell, like, write a comment, ask a question, put your problem into the comment section. I try to answer it, and see you next time. Thank you.